Good? Well start. Okay. You know, well start. Okay. Hey, everyone. Thanks for taking time to attend my session. I'm going to talk about how you can build your own AI assistant using JavaScript and obviously with all the hot buzzwords thrown out there. Okay. And this session is from a web developer's perspective, and that web developer is nobody but me. I've been in the industry for some time. I've built web apps, both front end and back end. And when all this tech came onto the scene, it was a little overwhelming for me. So this is part of my journey, my learning, and I'm trying to make it as simple as for you guys to get started. So yeah, if you're wondering, that's me and my dog as imagine my mid journey 2 years back. So I gave it a photo and said, okay, imagine me as a Pixar character, and that's the best it could do. So there you go. Couple of disclaimers, everything that I'm going to say is mine. And yes, I did use a little bit of AI help in the deck that I'm going to show you. So what to expect, we're going to take a look at what exactly is AI and how you can relate to it, trying to draw some parallel lines over there. We're going to look at what LLMs are, what vectors, what are RAGs, and we'll get started with that. Quick show of hands, how many of you here are technical, how many of you are non-technical here? I know it's a small crowd. Technical or non-technical? Technical, okay. And how many of you guys have worked with AI or LLM of some sort? Okay, still good. Wow, that's a huge crowd. Okay. Um, so here is, as promised, the fully buzzword compliance slide that has all the hot keywords out there. So as promised. But the reason I showed you that slide is the very first time you got started with that, all those buzzwords, right? When you heard it for the first time, was it a little overwhelming for you? You're like, it's moving so fast, I'm not able to keep track of it, right? So at the end of the journey, you climb that steep hill, you go up, and you're very anxious. And after that, you just realize what it is, and then you are in a state of nirvana, a state of calm, right? So I hope, if you are at the bottom of the hill still trying to figure out what this is, I hope by the end of the session I get you to the point where you understand this to an extent where you are able to relate to it in a simpler way and not be afraid of it. Afraid of it. Okay, so the first thing we need to understand is there are two kinds of AI engineers out there. The first one are the AI architects. So these are the geeks, the real AI geeks out there who does data cleansing, data labeling. They work with the cutting edge ML algorithms and build your net new models. These are the guys who publish models every week on Hugging Face and make your life hell, right? But then there are the AI chefs. The AI chefs are those people who, okay, knows there is a consumer problem or a customer problem that needs to be solved, and they take a model and try to build a UI, a good backend, and build a whole experience around it. And they are the chefs. They build for the customer, right? And I fall in that category, right? I play around with a bunch of models and I try to figure out how can I use this model or how can I solve something for my customer using all these models out there and do a lot of R&D and go through that process. So part of this is also how I approach these problem statements. Okay. Now, before we dive anything into AI, let's talk about HTTP APIs. All of us have worked with APIs. At least everyone knows what APIs are. They know that these are HTTP APIs that we talk about. These are your garden variety HTTP APIs, right? And I hope by the end of the session, W3C doesn't come up with a new HTTP method. They have the habit of doing that. So the question that I want to ask you is, how do you build your APIs, right? And again, the question that I really want you guys to think on is, do you really worry about how HTTP works at a protocol layer in the at the back end, or you just use a library like Express or Nest.js to build your protocol, right? Um, do you care, or when you start building your API, do you start by implementing the HTTP protocol or use a library, right? You really don't have to go into the fundamentals of HTTP protocol. A knowledge of an HTTP protocol is all you need to do this, because, hey, knowing HTTP 1.1 makes new connections for every API request, versus HTTP 2 or 3 can open a connection and send multiple requests, helps you build your apps better, helps you scale your apps better. That's the knowledge that you need. You need not worry about how HTTP connects to your OSI layer model and how packets are being sent out. You don't need that. You need to understand HTTP to a point. You need to understand the technology to a point where you can better understand and use it to solve your need. That's what we need to target. And that's where we are going to focus, right? We're not going to go into the core technology, but we're going to figure out how we can use all this totally buzzword compliant session to understand how we can use it to solve problems. So let's start. So let's look at how an AI works, right? And most of all, I'm guessing all of you would have used ChatGPT or Gemini or Claude at some point and ask it to, hey, tell me a joke. That's where you would probably start, right? So when you ask the model to tell you a joke, the model understands some things. It has some capability to process your request and give you a response. But then again, there are other queries where the model does not have access to that kind of data that you have. Like, show me my expense from the last night. The model does not know it because it's never trained on that. So it has to go look up a knowledge system in the backend, right? So that's the two-way a model is going to work, or an AI is going to work. And again, I should have started with this. I'm going to use the term AI and model and LLM interchangeably according to the context, but I'm hoping that you guys would be able to follow me. Let me just fix that slide. There you go. I fixed it. Okay. Replace AI with API. That's fundamentally how you build an API, right? You have an API where you send in a request and your API logic is able to crunch something and give you a response. Or when you want to call an API, that API can't provide you the data, it needs to do a lookup onto the database. Compare that with the previous one. Next one. It's the same, right? The AI is going to process something and give it to you. It's kind of like a black box, or it needs some external reference to help you out with that. So this is how we're going to approach the entire problem, okay? Let's look at what a model is now. Now we are getting into the meat of it, okay? And model is definitely not that model out there. So a model is nothing but a mathematical representation of the knowledge it understands, or a mathematical representation of the world according to the model. And what is this world according to the model? It's the information or the knowledge that it was trained on, right? Somebody somewhere, an AI architect somewhere, took a whole bunch of publicly available Reddit posts and said, here is everything that I know, I'm labeling it for you, this is your knowledge. And that's what a model is going to encompass. It's like a black box, right? You're going to ask it some question, it understands, it has a world view according to the knowledge and going to give you a response. And there are multiple models like that. Some models understand audio, some models understand video, some understand text, some understand language, natural language, or some of them understand many of this, and that's what is called as a multimodal model, or MMM, or There you go. Okay. Um, so that's a model. But when you start dealing with model, you need to have a way of figuring out what is the right model for you. These are the two tools that I go to. Okay, I'm not talking about ChatGPT or Gemini because those are hosted models. We'll get to that in a bit. But if I'm going to use my own model, and if I want to host my own model, and if I want to use it, these are the two things that I first go to. LM Studio, because it's a graphical interface where you can take a model, it gives a nice chat interface, you can upload your private document and ask it questions, and it just pretty much runs in your machine. You're not going to send anything out on the internet, right? Olama is a good system to use also. It's kind of like Docker, where you do a pull and then you run and use it. It's very easy to use. The thing about LM Studio and Olama is both of them gives you an API interface to hit and consume. And that API interface both of these give is pretty much similar to the API interface that OpenAI has published, right? How you interact with these models. So that's something that you could use. The next thing that you need to worry about are parameters, right? If you look at any model on Hugging Face, and you look at the example that I have here is Llama 3.1. You can see yeah, there you go. This is it has variations of 8 billion parameters, 70 billion parameters, and 405 billion parameters. So think about parameters as the brain size, the number of neurons in the brain. It's like the difference between a lizard brain, a monkey brain, and a human's brain, right? The bigger the number of parameters, the more processing power it has, the more understanding or the more clarity it has in terms of answers or responses when you ask it something. If I have time, I'll show you how that works, because I have a model that very confidently gives you the wrong answer all the time. Okay. So try to stick with models around the 1 to 2 billion parameter level, that fairly gives you an accurate answer. Anything below, it's bad. That's the example that I have. So you can go more. I'm getting to that. So does brain power mean more resources? Absolutely. So there are variations of these models. So when you, I don't know if you can see it, every model that you go and refer on Hugging Face, you look for this file called, and that's at least what I do, the safe tensor file. I treat the safe tensor file as the size of the brain. The lowest model here has a safe tensor file of close to 3 GB. The next one has two of those files, and the big one has multiple such files. So that brain is essentially what needs to be loaded onto the memory for the model to compute and understand everything. So if you don't have that many resources, that model is definitely going to take a lot of time to come up and start processing, etc. Right? So what does this all mean? Again, I have 2 decades of experience. When I came to understand this, I stopped complaining about Java application. If my Java application says it needs 16 cores and 8 GB of RAM or 32 GB of RAM, there you go, take it, run it. I have no problem with you because you run fast compared to this, right? That's now, this is where the distinction between a CPU and a GPU comes in. The only difference you need to understand between a CPU and a GPU is a CPU does instructions sequentially, it does one after the other, but a GPU can do it in parallel. So a model runs much better in a GPU because fundamentally at the end of the day, it's a mathematical model and it's going to crunch, or it has the same equation with multiple inputs running the same thing in parallel. At the end of the day, it's going to look at those numbers and give you something. So GPUs are better if you are going with your private model setup compared to CPU. And there's a whole YouTube link that explains that. I have links to that. I'll share that with you guys. So we understood what are models, how much the brain power, the parameter size, and what is needed to run it yourself. The next thing you need to know about a model is its knowledge cutoff. So you look at the fact sheet and it tells you what's the cutoff date of the knowledge that model understands. Over here, the Llama 3.1, the cutoff date was December 2023. What happens if you ask it questions very recent, it will very confidently give you a wrong answer. Okay, that's what's going to happen. So the question then is, what if you want your LLM or your AI to work on your private data? Okay, like the question that I asked, how do I find my top 5 expenses from last night, right? So that's where RAGs comes in, or the retrieval augmented generation comes in. Before we go into RAG, you need to understand one more thing, embeddings, because this term will also keep coming into picture. Think back about the earlier diagram I showed you regarding an API. An API, when it wants data, it goes to a database and picks data from there. That data is in plain text, English, or something that you need to understand, that the API or you can understand. But an AI, because it's a mathematical model, it does not understand clear text. It needs to make relationships out of the text in it. So embeddings are nothing but a way of representing plain text, language in this case, into a mathematical representation that has some relationship with words and other things. And you kind of put all these embeddings of different documents or different text into a space to create a vector space. And that vector space is clustered in a way where that information is kept in the database with some clustering around some relationship. Okay, that's all you need to know, that embeddings are mathematical representation that creates vectors, and you have a vector space which are multiple vectors bunched together. And a vector database is nothing but something that helps you manage your vector information like a database, right? And you're definitely not going to do a select star from table here. You're going to query it with some parameter saying that, hey, give me data which is similar to what I'm trying to find out, right? You're doing a semantic search rather than a select star from whatever table. That's the difference here. Now, once you have your vector database, and I'll show you some code at the end, let's get back to what retrieval augmented generation or RAGs is. It's quite a mouthful, RAGs, okay? So under the hood, this is how a RAG works. You will ask, you have a question, you will go look up the data or do a semantic search from your vector database. You will get set of results because that's a response that you get, and that's the context. You take that context along with your prompt, which is what was my last or what were my top 5 spends from last night. Give it to the LLM, and LLM is going to take that context that we retrieved from the the vector database, question, process it, and give you a response. This is how you plug in your private data to it. And if you want to completely run it privately, you run your model on your laptop, machine, your server, wherever it is, host your own vector database, stuff works pretty much the same, right? That's all there is to it. Now let's talk about where ChatGPT, Gemini, Claude, and the likes of it comes in. I told you that running a good model is resource intensive. It takes a lot of computational power. It takes it takes a good machine to run it. These systems out there, they are multimodal. That means they understand text, images, voice, video, everything. This is like a pay-as-you-go model. They have APIs to which you can send your context as well as your prompt, and you pay as you consume the APIs, and then you can start using it. This is a good way to get started if you're trying to build a Hello World equivalent of a program to get started, or try out some POCs. But the moment you are trying to deal with enterprise level data where it could be secure and you don't want it to go out, then we are looking at a hosted model kind of situation. Okay, code time. I hope it's clear. So again, written in JavaScript. The reason I want to show it in JavaScript is, look, it's if you're new to it, it's a lot of await async calls. It's easy to plug this into your API call, wherein so what's happening on the screen there is you're setting a context saying that, hey, you are an assistant, you're a helpful assistant, and I want to know the capital of the country that I'm going to plug it in here. And I'm using a very small model here. And when you ask it, hey, what's the capital of Italy? It's going to give you a response. That's it. That's all it takes to run. And this pretty much comfortably runs on your machine. That's all it takes. And if I want to use it with a vector store, the stuff on the left-hand side is me creating a bunch of context and other things and initializing a vector store, which is in memory. And the stuff on the right-hand side is how do I add a document? That's the entire load the document into, embed it or convert it into a vector format and then add it to in-memory store. And the code over here is, hey, what's the available parking space? It does a query, it gets the response, which is here under docs, and then I pass it to my model and say, hey, I want to know what's the available parking space, summarize it, and here is the context to it, and it's going to give you the response. Okay. The model that I use here is a Llama 3.2. I think it's a 2 billion parameter one. Again, that runs on your machine. No worries on that. That's it. And before I jump into the code and show you some stuff that goof ups that models can do, that's a link. I've put the slides, the session notes, couple of cool links that you can look at, including the link to my repository over there where you can just take a look at, critique it. Don't comment on my code. It's a quick POC code, not production ready. Don't use it. Test it before you use it. Okay. How are we on time?
5 minutes.
5 minutes? Oh, we still have time to show the code. Not the code. Let me show you what I meant by the confidently giving you the wrong answer part. Okay, you guys can see? Okay. So the first one is, I'm going to ask it, what is the capital of Italy? Let's see. It says Rome. It says Florence. Very confident. Again, it's Rome. It's Rome. Okay, okay, there you go, Florence. Okay, that's the confidence level it has. And under the hood, it's running, I think it's running the smaller parameter. Yeah, it's running the 0.5 billion parameter, slightly smaller. It's a lizard brain that's running. It's very confident in its answer. It's not going to give you the right answers. But whereas if I use something like, see, if I have a Gemini model, yeah, if I ask Gemini, oops, nope, you're not going to find my API keys in the repository. Don't worry about that. that's going to give you a bit more confident answer, and it's going to be consistent because it understands, it has that context, right? So um, again, if I want, I can also show you LM Studio. That's also a neat tool that you could use. That's LM Studio. Neat way you can find out models that you can use. You can use the Llama instruct model, say load model, and then you get a chat interface where you can upload documents and talk to it. The good thing about LM Studio is that it always gives you the CPU utilization at the bottom. It tells you how much RAM CPU it's using, and the moment you know your laptop, fans kick in, this is the problem. Okay, so there you go. That's how you can get started with. That's all I have. I hope took away something from here, and it's a little more easy for you guys. Thank you. Again, I'll be around for 2 days. Oh yeah, please go.
So Apple just released Mac Mini.
Yeah.
And it's a great computer. It's pretty budget. And have you heard about using them, but not one, but several of them, like 2, 3 in a rack?
Yeah.
How you can use the models on them?
I've not looked into it. I've heard about it. Again, the way I give out feedback is I need to try it out because only then I'm confident. So I've read about it. I don't know how feasible it is. But I'm in the works of trying to build my PC box. It's very difficult because the last time I built a PC was 20 years back. It was very easy to pick up a motherboard, a GPU, etc. Now I'm looking into GPU specs and trying to figure out what is the GPU that I need, purely because I want to see what it takes to run your model privately and other things. Right now, whatever I do, it's on the cloud. Okay. Yep. Sure.
Like you mentioned, as you add more parameters, the hallucination effect reduces, right?
Yeah.
Like you just showed
Yeah.
Florence versus Go. So how do we measure the accuracy? Let's say I'm trying different Hugging Face models. I want to balance between the cost and the accuracy. What metrics do you, because it's what I understand is mostly stochastic, right? It's not
Yeah. So that's why you don't put your model directly into production yet. You go through a phase of, in the industry, it's called MLOps, where you train it and you do it testing cycle, and then you figure out, okay, how confident it is. The problem with all of that is it's a very human intensive thing where you have to go through it and figure out. Don't ask it to predict things, because that's where it really starts hallucinating. But if you want to look at data and ask you to summarize, that's where it mostly gets it right. Okay. Sure.
Yeah, I was curious about showed the Quinn.
Yeah.
Hallucinating. Have you seen the effects of using RAG on smaller models? Better?
Yes, the Quinn model, I used it in my example. You can change it to Llama, and if you ask it a question, it more often it tells, oh, I'm not able to find that context for you, or it's not going to give you a good enough answer, right? Let me see if I can. We're good on time?
There's not another speaker after you. We're going into open networking now.
Okay.
So I figured you can show some more stuff. People want to see it.
Okay. So this is the RAG model where I gave it a bank deposit letter. That's mine to that, and I'm asking, hey, tell me more about the parking space, right? If I ask the same question to the Quinn model, which is a smaller model, it will not give me a good enough answer. Even the answer this model gives also is not great, right? So I'm specifically looking for the information around the parking spot. This even ends by saying that there are two missing details: the parking space area, and that's a huge parking space. That's not the parking space. So even with a good model, that's the size of a house. So even with a good model, it's still not able to give a good enough answer. That's where you need a little more computational power to understand these things. And yeah.
So have you compared maybe like RAG as opposed to fine tuning like smaller models in the performance background?
Not really, because when I want to use it for my private data, I'm piggybacking on Gemini, because my thought is, well, Google knows pretty much everything about me. What am I trying to hide from it by keeping my rack private, right? So I use the open Gemini API model, being very truthful here, and I use that to query my private documents. Okay. Okay. Cool. That's it. Thank you, guys. Thanks for your time.